to rotation of the wheels. Here output type is same, input types are different. And because like sometimes you go to the petrol pump and say, sir, power sir. When I first heard it, I asked back, so what should I do? Good, you have a power. Even Himen says I have the power. What should I do? Like Himen, type of the petrol, sir. I was like, okay, put it. He didn't tell me it is going to cost me a little extra. Maybe I should have realized it. I was studying too much of computer science and type of petrol, okay. Sometimes it doesn't mean the same. That is why it is important to realize types do not mean values. Types are types. It may make your car work, but not your pockets. Right? So, types to output. Both are important. Sometimes you put petrol but the wheels don't rotate. That's also existing, right? That also happens sometimes. But you are not getting the output. Essentially, you have to satisfy the contract. Only then it works. Okay. So for example, what is the contract of plus? What does it take? What does it give? Not any type. Yeah, same type, but not any type. So we cannot just say same type. You have to be specific.
Number.
How many?
2.
Not more than 2.
2.
I cannot write 10 plus 20, 30. 2. It takes 2 numbers and gives 1 number. That's a type. What is the type of multiplication?
Takes 2 numbers.
What is the type of AND? We did this in the second and third slide. 2 logical values and gives 1 logical. Exactly. Does this make it clear? How many concepts did you using, right? Maybe we should have had coffee instead of tea. You must have written it down, right? Now fight with each other. Who has written the maximum one? How many you have written maximum concepts? Somebody gets 4, somebody gets 5. Substitution by type, that is also a concept, right? Substitution of type, substitution of values. So even if you don't explicitly say it, right, there are many concepts already being covered. That's why I said please do not start the computer. Now there is something interesting about all of this, right? It looks rather abstract, but it is not. And I'll tell you why. Should I ask something? I'll try 2 ways. Let us see which one works. Okay? But I still want you to break your head over it. What is this? No, but what is it? I get what this is, but what is it? What does this whole thing express? Yeah, that's a good contract, but what does this whole thing express? does express something very interesting. That is confusing, right? To answer this, let me slightly ask the same thing in a slightly different way, okay? Take a look what I am doing.
Pythagoras.
Yes, Pythagoras. But let's say if I don't give the values of x and y, then what? What does this say, okay? Take a look at this. What does this express?
Draw a circle of a particular radius.
You never said this is also a circle. Did we think this is a circle? We could easily identify this to be a circle. But we couldn't identify this to be a circle. Why?
Here type is the radius.
Is that the case? If this was pictured on x in bracket r, would you have understood what this is?
No.
That's right.
Naming.
Naming. In case you don't believe me, let me show you something. Okay. The interface here is pretty familiar, right? Look at that part. Okay? Looks exactly like if I start Kojo and say clear, show axis and show grid. That we all have done. Okay. So, for example, I have Kojo here. Don't open the computer. I'm just increasing the font size. Okay. So clear, right? Show axis and show grid. And then there is what we get. Alright? Now if I go here and if I type that x square, should I just make this bigger a bit? Plus y square is equal to, first I'll just say 2 square, then I'll change it to r. 2 square. What did it give me? Now I'll change this to r. Right? And I'll add a slider for it. Now, if I increase the value of r, same thing, right? But we never thought that first one is a circle. You know why? Because we were never told this was to be solved in a graph paper. You were always told this is to be solved with another equation. Equations with polynomial equations with 2 variables. How much marks did it get? Those who never solved it got this. This is the language of mathematics. We'll quickly touch upon what this means and why it is so. Okay? But I want to do something else. Do you see here x square plus y square is equal to r square? We generally say mathematics is a very, very difficult thing, right? Well, everything is difficult till we start understanding it, just like even English, right? For a lot of time I didn't understand why CAR is car but CAR is care. not Kari. My father was an English teacher and he was teaching in the same class as what I was there. So he comes in a classroom and says, "Can any one of you tell what is a carpenter?" I'm like, "Yes, sir. The person who paints the car." When my father stopped asking questions in my class. So it's confusing at times, right? It happens always. But here is what I am going to do. Do you see this x square plus y square is equal to r square? What happens if I change that 2 here? Power of 2 is right. With something like 4, 10, 100, something like that. What do I get there? Have you tried? So if I say 10 here, sorry, not 2, 10, 10, and then 10 here, and then 10 here. What does it become? How much change did it take? Now if I ask you to change a square in Kojo to something like in a rounded square, right? It will be a lot of fun, isn't it? Mathematics is simple, you just need to be able to understand it in the right way. This is the language of mathematics. This is not about solving it. Spend an entire classroom session breaking our head trying to solve it. But the ICT curriculum is different. ICT says, you know what? Computer should solve it. I should tell the computer what I should get. But quickly enough, let us quickly understand why this is so. Okay? Do you see that x and y? Now we have not defined it. We had to define r though. Because we were given something on our plate. What is given to us on a plate? What is that? Oh, what do we call this? The whole thing. Not x and y, but what do we call it? Yeah, graph, but coordinate plane. That whole thing is a coordinate plane. And coordinate plane has how many values? A 2D coordinate plane has only 2 values. Everything that is there on a coordinate plane is just 2 values. Everything, okay? Everything is just 2 values. X and y. Doesn't matter what. X and y. Everything that you do in the world, right, is with x and y. What this literally means, when I said x square and y square is equal to r square, it basically means, what is this equation, right? Equality. Ease, keep this in mind, okay? Ease. And x and y is known. All the x's and all the y's. So what is this one saying? Can you guess it? If you take all the values of x and y, then the points where that x squares plus y squares value equals r square, that is what we are interested in. It's a slightly different thing to say. It's saying for all the possible values that I see here, we are not asking you to solve it. Something we need to say. For all the possible values of x and y, because coordinate geometry is always 2 values. You want to draw a square? Fine. Only x and y, please. Draw a circle? Fine. Only x and y. Want to draw any other curve, arc, doesn't matter. X and y. Rest everything is unknown. But if you say x and y, all x's and y's. Possibility of all x's and y's. Now if this gets confusing, right, let me simplify it. think about this and tell me what is this one going to be. Take a deep breath. Think for a while. Don't start jumping around. Do not try it on the screen. Just think about it in the head. If I say y is equal to 0, y is equal to 0, do not try and solve it. We'll solve it here together. Think about it for 2 minutes and tell me what will y is equal to 0 draw.
0.1.
Just 1 point? Remember how we said here? All. The moment I see x and y in a coordinate plane, all x and y's. What does this tell you? How will you read it? First read it. Horizontal line. Set of all y's where y is 0. Set of all possible x, y where y is 0. Set of all possible x, y. Two value always, whether you write it or don't write it. Set of all y's where y is equal to 0. Okay? Take a look. Y is equal to 0. Do you see that trend line? Draws you a line. What if I say y is equal to 10? Or let us say 4. How will you read it? Do not solve it, read it. It's like English. You just need to know how to read it. How will you read it? Set of all x, y's, set of all x, y points. Set of all x, y points such that y is, what is that?
Line.
But from where? So if I change this to 4, yes. Set of all x, y. See, I have not said what is x. Have I said what is x? No. X could be anything. So all x, but y has to be 4. Now what happens is this point here cannot be that. Why? Because y is 2. But here whatever the x may be, that is the only point which can say y is 4. Doesn't mean anything else. That is how you are supposed to read it. Do not try and look at, oh, y is equal to 4, y is equal to 4. Supposed to read it. It's written that way, but it's to be read in a particular way. Means set of all points x and y, because this is 2D, 2-dimensional. Set of all x, y points such that or where y is equal to 4. That is how you are supposed to read. Now why does that first one give me a circle of radius r? Why? Have we, you know Pythagoras theorem, right? Now when it is drawn or when it is taught to us this way. The line is drawn, right? Then we do this. Everybody has a lot of patience here. The students are here. This is x, right? This is y. Then the teacher puts here z. Correct? Why doesn't she move further? Because she runs after the alphabet. There is nothing after z. Then comes physics, and they're like, no. We'll say z dash also. So the teacher says, this is x and this is y, what is z? A lot of students says, ma'am, x plus y. And teacher says, no. Some great guy called Pythagoras had no other work to do. So he wrote z square is equal to x square plus y square. And because he said so, it is so. And we believe it. Then we read the text. The teacher says, who asked you to believe? Here is the proof. Now you by heart the proof. If you don't, you will have to write it in 10 seconds in the final board paper. Right? So, anyways, we are not running after proof. Just understand one thing. Essentially, what it is trying to say is the length of this is the square of x and y. X square of x plus square of y using square of this. Now, how will I read this? Now, this is confusing because there is a problem of having z. And the moment we have z, right, just like this was more understandable, right? Because we named it properly. If we name z properly, right, this suddenly starts making sense. This z is nothing. Now take a look at this, okay? This z is nothing but there is a point here, x, y. This z is nothing but distance of x, y from center. Now if I say, take a look at this, okay? X square plus y square, okay, is distance of x, y from center square. Does it make sense? Does it make sense?
Yes.
I just replace z by saying something. It is a distance of that point x, y from center. Okay. What is the radius? What is the radius? Distance from the center. Distance of any point of circle from its center. Is that right? How do you read this then? How is the circle defined? We did this, but we had a very, very long step to explain in the 6th standard. Those who successfully taught drawing a circle to kids. Why we used to send somebody forward, get the cat back, then rotate, send again the same distance forward, get the cat back, rotate, send the cat same distance forward, get it back exactly by the same amount, rotate and do so. Why? Because center is all the points at the same distance from the center. Now, we remember how we read this? Let us try and read the same thing in this way. Set of all points x, y. Set of all points x, y, which is at the same distance from the center, R. Set of, so this is set of all points, because this is the distance, right? This is the distance. And R is a value, it doesn't change. So R won't change. So we can say set of all points x, y whose distance from the center is always R. What does that make it? Circle. Obviously it becomes easier if we say it this way. Enough of brain term, I promise. Now we'll have a headache. Take some time, let it digest, we'll move over there. Okay. Has everyone written this down? you already have Linux installed, you will have GeoGebra, you can use it in offline mode. You can try the exactly same thing. Else you can use it. You will have a separate section on Desmos Pilot. Because you can do a lot of interesting stuff. We don't have enough time.
आमची क्लास इतली थंड आसना सेवरा थंड पडल्या
All I want to show, right, is sometimes numbers are fun and those equations are not that bad. And they mean something. Now, who can draw a scenery with just this? It's rather easier. We just have a bit of practice. All those sceneries and everything that we drew, right? In 7th standard, 6th standard, you can do it just by writing few equations. Once you know which equation corresponds to. Okay? All good? The point I'm trying to say is it doesn't matter. I'm not asking you to prove anything. I'm just, what matters is what it means, what are the types of the inputs, and what is the whole contract. Rest everything will figure out. We talked about functions, right? So we wrote something like, I'll write a function how it looks in Kojo. Okay? Let us try something. Okay? Def 10 is equal to 10. Is this correct? Def 10 is equal to 10. We have done this. All of us have done this. Who didn't do? Sonal may be sitting over there. What about this? Def increment. Okay, just a cautious point, okay? Even though I say it right, do not say in front of students def. They will give you def use. You should say define. Define increment as x, let's say int. You can say long also. Int is equal to x plus 1. Is this correct? Is this correct? We have done this, or we haven't done it. We haven't done a def. Define. What are we trying to do here? What does it do? What can I substitute here? Can I put 10.0 here? Why? Contract. Int. What will I get here? So if I give here 10, just 10, okay, not 10.0. Will I get 11.0 back? Why? Contracts. Make sense? X is whatever the value you can give, which is the integer. For that, you will get the value which you will get by adding plus 1. Okay? How will you see the contract? Increment is takes int, gives you int. This is a syntax, this is not. Okay? This is how to read it. Increment is a function that takes integer and gives an integer. Okay? there is another type of, let's see another type of value. Okay? Now here 10 was this, right? Picture dot circle, okay, 10 is a picture dot circle dot 10 is a, it's a value. It's a value of type picture. It's a value of type picture. Obviously, it's not a number. However, this is a number. But picture dot circle is a picture. Okay? Now, let us do some few things. If picture dot circle is a picture, def circle is equal to picture dot circle 10. Is this correct? Fine. What is the contract of circle? Contract, okay? Contracts only talk in terms of type. Does it take an input? Does it take any input? No, there is no input. It only gives the output of type picture. Circle gives me picture. Whose value is circle of radius 10. The way we read things, right, is important. Because when we don't read them properly, we cannot put them together. Good enough?
So is circle a keyword there? The circle 10.
This one?
Is that a keyword?
That's the name of the function.
And what is that circle? So there won't be a clash.
No. We'll talk about what this is.
No, that circle.
Because this is just circle, this is picture dot circle.
No, but if you mention that circle, won't there be a clash of the keyword and the name of the function?
None of them are keywords. This is the name of this whole value. And see the names are different. Do not get confused with this, okay? One is just circle, another one is picture dot circle. Picture dot circle is different from just circle. Correct, right? Just like carpenter is different from car, even though there is car in it. Just like car is different from cars, even though both have car in it.
That TEN is the name given to a number 10.
So, who's question? Yeah, good. Ma'am.
So we have 10, that doesn't become because that's the
This 10? Now, picture or circle is a function that inputs, that takes some double as input.
So in the second example, is it compulsory to put int after that, the type, or automatically we generate out print digit type?
This one?
Next one.
Here?
The next one. So say second example.
This one, picture or
So
circle?
second example, define increment x int, again you are putting int there, no? After
Yeah.
that.
So this is the input, this is the output.
No, it's compulsory to put that int again.
It is not compulsory, but it helps you to read it.
Yeah.
Otherwise you get confused, what is it written for?
But will it give error?
No, it won't. It won't. It won't give an error. Okay?
We used to mention unit.
Unit will also come. You saw that it was there in the slide, right? Unit was there, but we'll reach it. Is this clear? Okay. You saw picture dot circle, right? Similarly, we have picture dot rect. We have more. We have lot of them. Okay, we'll go through all of them. There is a slight difference. Like, what if I now say def circle? Okay, I ask for a contract. Okay, def circle R is double, gives me picture. Is picture dot circle R. Is this correct? What am I saying now?
It will accept,
Yeah.
it will accept input in double, that is decimal, and return a picture.
So contract looks like circle
R,
circle which takes double as input and gives picture as the output. Okay? Good enough? It depends on how you read it, okay? Be careful. Before you solve it on the computer, right, you should be able to read it. You have to get the reading part right. This circle always gives me a picture. But this circle here, obviously if you write both of them together, right, it is going to cry. So just separate things. This circle only gives a picture. This circle takes a double value and then gives you a picture. Okay? Always understand one thing. By convention, okay? Because, what do you mean convention? You understand what is the convention, right? What is the convention? Somebody said so. Somebody with an authority decided so. When a chief minister or prime minister takes a oath, right, what do we say? मैं विधि द्वारा स्थापित किया हुआ. What is that विधि?
rules, set of rules.
We're following a process, vidhivat. We're doing it vidhivat. We followed a set of process, and through that process something got set up. Right? Basically mean, it feels bad when it just one person says so. So that one person gets 10 people together, makes them say so, and then it becomes vidhivat. So then for the next 50 years everyone keeps saying the same thing. Not related to this example, but we know dogs, right? One barks, everyone barks. Why I give that example, I don't know.
Sir,
Yes, sir.
def rectangle is equal to picture dot circle dot 10. State. Def rectangle is equal to
Yeah?
picture dot circle
Yes.
in the bracket 10.
Yeah. Yeah, correct. Contract wise it is correct.
Yes.
Contract wise it is correct. But somebody is going to say probably you don't understand what circle and rectangle looks like. Or maybe like a body of mathematicians decided and said, okay, from today's rectangle is circle. Like that. If we say so, it's error. If mathematicians say so, it's a new discovery. This is the difference. That's why it is important to PhD. Because then you can make a difference by making mistakes. Nobody with a PhD degree here. Anyone? I was just joking. Okay, so let's proceed. A slightly different. So by convention, types are always written with capitals. Okay? By convention. What is the contract of? First write it down, then dictate me over here. But let me first write it. Picture dot circle. What is the contract of this? Complete it. Just picture. Contract. Asking for a contract. What is the contract? How is picture dot circle ever written? If you want to draw a circle, what will you say? Never forget the input, okay? That's why contracts are important. See how quickly we made a mistake? That's why contracts are important. Everybody gets it now why this is important? Otherwise tomorrow you will have a question, why did you put the bracket? Because picture dot circle is not a type, that is that only gives the output. What is the type of this? Or a contract of this? It takes in double and gives. Okay, I'll give one more, okay? Picture dot rect. Correct, but types. What are the types? Doesn't take integer. Double, comma double. Gives. Alright?
So why not integer?
Because it is defined so. Seriously. Because it is defined so. Do you see this? Take a look at this, okay? Doing something. Picture dot rect. What is here? Is there? Double gives picture. Because it is defined.
We will not be able to make this middle point of them. There are numbers in between 4 to 5.
Yeah.
Yeah, that is
Correct.
why must be.
Yeah. But you would have very well said
Yes.
integer, then you would have like increments. Big increments. Which is fine, but did you see that? Or the other one, rectangle is also there. This means the same thing, but double gives picture. Okay? Now understand one thing, okay? Picture dot rect, if I am not given input, is double giving pictures. Fine? Sir, put it. Somebody complained, my all photos are like this. Either I can't give a pose or somebody is a very bad photographer. So, double gives picture. Now if I say picture dot rect, but if I do not give a value or do not give inputs, it is double giving picture. But if I say picture dot rect and say 10, 100, what is the type? If I say picture dot rect and put in a bracket give 10, 100, what is the type? is how it becomes. If you give this, the type is this. If you have this, then the type is this. If you do not have this, then this whole thing is a type. That is the contract. Okay? It's like you complete one step at a time. So over here, take a look at this, okay? I'll say def circle is equal to picture dot circle 10. What is the contract of this circle? Not that circle. This circle. This one. Circle. There is no inputs. It is just picture. This circle and this circle. There is a difference. This one takes the input. But this circle directly gives me a picture. This one doesn't. But if I have picture.rect and did give a double value to it, what I get is after this is picture. Still confusion? Okay. Is this clear? This is easy to understand? Circle gives me picture. No reason. Right? If I try and call picture dot circle, what is this value? What does it give? It does give me something. That is why reading it is important. This one, this picture dot circle gives me a function that takes a double value and gives me a picture. Okay? See the difference between this and this. This circle gives me a picture. This circle gives me a function. See this. This is a function. And this is a value. Okay? This circle gives me a function that takes double and gives me a picture. This one directly gives me a picture. But just because picture.circle gives you a function doesn't mean picture.circle of 10 gives you a function. What does picture.circle of 10 give you? Of what type? Picture.circle is not a picture. Look at the concept. But picture.circle in bracket 10 is a picture. Okay? Never forget things that have inputs.
So that's contract how we write in defining how to define.
Which one? This one?
Yeah.
Like this.
Like how we write def and all.
No. Def is a function. That's the syntax. That's how you will write this in.
So what is the syntax for that?
Like this. Like this.
So what did 4 points mean?
What is it?
The 4 points, 2 columns.
This one? It means contract. Picture.circle's contract is that it gives me a function which takes double and gives a picture. This circle's contract is that it only gives me picture. Okay? It's fine. At this point, if it is a little confusing, right? It's fine, but write it down. Because when we'll go to Kojo, right, you will have questions on why. Then I'll ask you to refer it back. And then it would make sense. It still gives you. But what it gives you is not a picture. It is a function. This is a function, this is a picture. This is a function, this is a picture. So let me slightly show it to you. Kojo is a slightly advanced syntax. Slightly advanced. It didn't show you, but let me prove my point. Okay, using Kojo. Okay. Now take a look at this. Okay. Can everyone see the screen? I'll get rid of axis. Okay. And I'm going to write something. Take a look. Try and read this, okay? That is why do not do it on the screen. Emphasis on reading it and being able to write it. Coding or typing becomes easier. You all are good in typing, sorry. So do not go there. Otherwise, what follows next will always become more and more confusing. Because there were some struggles with pick stack and all, right? Pick stack, then rotating it, rotating one part, translating the other part. Correct. That is because there was a difficulty in pick stack, so it is all related. Because the moment I ask one square to rotate this side and another square to rotate that side, right? Do you think there are two different pictures or one single picture? Then why does one rotate this side and another rotate that? It's still called once. Because you can only draw one picture. Okay, let us try and see this. Depth circle, okay, depth circle is equal to picture dot circle. What should I say? 100. And then I am going to say circle dot drop. Okay? Normal Kojo. We are all very good at it. So, if I run this, I get it. Nothing big. I am going to make a slight change, okay? A slight change. And when I say slight change, it's really a slight change. I am going to remove this and I am going to put there underscore. You just remove that 100 and you put underscore. Now what? How will you read it? See, I didn't change anything here, okay? I only changed there. How will you read it?
Draw a circle with radius dash.
It's unknown. It's unknown. Is this a syntax error? It's not. Remember the way we wrote Z in mathematics? Z is equal to 20 plus X. X is something unknown. If something is unknown, where will somebody try and find it? In the input. So there is something unknown. It is expecting an input over here. So suddenly, take a look at this, okay? We will come to know when we run it. This, when it was written this way, this circle was giving me a value of type picture. But when I remove it and replace it with some unknown underscore, it doesn't directly give me picture. Because it needs to know what is there in that underscore. So now this circle gives me a function. That function first says, "Mama, पहिली ते किती देती मागे राव picture." भुरगी करतात. होमवर्क करता ना. पहिली पोगो. So, if you want to try, let me run this and see what does it say. Did you read the error? did the error. Value drop is not a member of double giving picture. Did you see that? Suddenly they draw here. This circle, value drop. Value drop is not this drop. He is saying this value is no longer this value here because I have not passed the input, right? It is not double giving picture. It is not double giving picture. Which means it is expecting a double here. And the moment I give it a double, now it will do. Doesn't matter. Doesn't matter. It is some unknown. You have to pass it as an input. It just helps you to know. Giving them names only help you to know which input goes where. Otherwise it is confusing. But in this example it was okay. It was taking just one unknown input. So that was fine.
So instead of that underscore, we put any other sign, that will work?
No.
We have to put underscore.
It has to be underscore. It has to be underscore.
Can be a when.
It's exactly how we deal with students, right?
Wow.
Right? We'll give a question and say dash, right? Why we say dash? Because one fine day, the teacher gave a paper. And teacher said, find the value of B. Or circle the B value. Right? What did you do? A, B, C option was there, right? He circled D. In the options. Kids are very smart, right? They actually behave like computers. And if this circle looks like a bit of an ellipse, it's because of the projector. Okay? Now, so understand this, okay? When this was not there, this circle itself was a value of type picture. This circle itself was a value of type picture. But when there is an input associated over here, this circle directly does not become a value. To make it a value, you have to first give it the input. Like that. Obviously, you can change. Let's say 10. You draw a smaller one. Is it to understand now? This picture dot circle is not a value. It's not giving me picture. But this one is giving me picture. Now understand the rules of substitution. Okay, has everyone written it? Yeah, you can increase the number. You can increase the number. Different sizes. Yeah. You can go on increasing the radius. Alright? Everyone wrote it, right? Rule of substitution. Let me put 100 here. So now this circle directly becomes a value. This works. Take a look at this, okay? Rule of substitution. If circle is a value, I can substitute it with whatever it is expressed with. So I can directly take this, put it here, and that works. resolution. You see some definition, you can go either from left side to right side or right side to left side. And wherever I see picture dot circle, because I have exactly the same thing defined to be circle, I can directly replace this with circle. And that works. Okay? Fine? There are many of them, okay? I'll just quickly go. Making a small change, I'll call this a shape. And then this becomes a shape. So this shape is a circle. This shape is a circle. If I change this to rect, this will cry. Why will it cry? Look at the contract. Right? This says 2 doubles. So it cannot give me, draw requires a picture value. But it cannot give me a picture value. Because it requires one more. I will give it one more. And now it gives me a picture. So it draws. Okay, great. So, picture dot rect is there. Do you see all of this? There is button. Right? There is a button there. Then there is a circle. There is an arc also. And if I say arc, take a look at this. It asks me for a radius and an angle. So radius is 100, angle is 90, and I get that. Okay? If this is confusing, I can say show axis and show grid. Is it to understand?
Yes.
90 degrees. Okay? Then, once you are done with arc, there is ellipse. Okay? See, there is ellipse. Ellipse takes the x radius and y radius. So, x radius. So, if I give the same radius, if I give same radius to ellipse, it becomes a circle. But the thing is, I can increase it either on one side. Like that's an ellipse. Okay? Then obviously there is much more. There is canvas, there is path, there is scratch, there is turtle, there is vertex. There is lot more. There is a point also. So if we say point,
Not with.
there is just one point over there. It will not be visible. There is. But it didn't give an error. What is that? It doesn't have a size. It's not a dot. It's a point.
Point. Yeah, but you can give coordinates to the point.
But you will never see it. It's a point. Okay? In Blender, so this is why, right, everything that we have done previously was very, very important. In Blender, there is a concept of a vertex. Now that vertex, right, never gets rendered. That vertex never gets rendered. So why is it there? Because somebody said so. Even if it doesn't get rendered, right, it allows you to do something. You can set a camera to track a point, and then you can animate the point. Even if it doesn't move, and then doesn't render, you can change the way camera focuses by changing the point. So it has a meaning. Okay. Then there is obviously from canvas path, we'll do all of them. There is a show bounds, gap, widget, many other things are there. But at basic it is this. Obviously there is from path and from canvas and all that kind of stuff. Most importantly, we will do from paths. We can do from canvas also, but path is also interesting. It is something important to see. But idea is we are building a value of type picture. For example, there is no triangle here. How will you make a triangle? You can't make it using a rectangle, right? Yeah. Is there a line, by the way?
Yes, yes.
Yeah, there is a line. There is a width and a height. So let us say 150 and height is 2. And there you go. Now you can put 3 lines together, but you know what? It will not be a shape that you can fill with. You will get one object, but you will not be able to fill it. So these options are there. There is an arc, there is a line. So if it's just an outline you can draw, you can use this. But obviously you will see much later on. A lot of it forms a part of the 8th standard curriculum because 7th standard was mixture of picture and turtle. 8th standard, you have to rotate it there. Rotate it. Then rotate it. That's rotated. See? That is not an angle. It is a size, height. So, that's not actually an angle. That was possibly a bug. Because let's figure it out. That's a good point. I think maybe what it's trying to do is it's trying to form that, just like we have a line, right? The actual equation of line is y is equal to mx plus c. So there are 2 values over there, the slope and c. So it is taking one of them. 150 is the length. And it is splitting the other one to be. Here it says height. It says it represents height. It is something like that. If it's a circle and written a rectangle. Yeah, obviously it will go straight. Because it is designed as a slope. 150. And it is saying height. So, say 90. It will go straight up. Now. The height of the rectangle where it sort of draws it. So, if I say 150 by 150, it will make it a 45.
150.
It is then x and y.
X and y point.
It is this and then this. Slightly confusing.
X and y points
So it takes this as a center. It is then this point. Yeah, starting from the center, what is the other point? It becomes 150 by 150. Slightly weird. It's not width by height, it is basically the x and y of the other point.
TV 19.
So if you want to make it straight, I'll say x is 0 and y is 150. So x is 0 and y is 150 and that will give me a straight line. Make sense? Alright? So good enough time to take a break. Give some food. You can think about it, then we'll come back and then we'll transform it, then we will animate it. Because animation requires inputs. Something changes, right? Always. What does animation mean? Change. So if there is a change, it has to take it from outside. I hope everybody must have noted this now, right? Now, if you see something, right, these are giving contracts and we will see how each one of these maps when we actually write this in code. We also start giving us an idea why the contracts are important. Do you see how the plus is defined? Essentially everything that is there in quotes, right, should be written as is. Obviously not with the quotes. But what it says is everything that is there in quotes, write it exactly the way it is, and everything which is not in a quote, except brackets obviously, is a value. Right? So, if I write double plus double, obviously things won't work. What this means is put the value of type double here, plus put the value of type double, and you will get back double. Make sense? Let's try doing it here. Any of double type, 10.0 plus 20.0, and what would this give me? Set. That gives me double back. Right? And the answer is 30. Correct? So double plus is to be written exactly how it is. Double plus double gives double. Alright? What is the next one?
Double minus double.
So double minus double also gives double. Right? Is that correct? Double minus double gives double. Now why is this important?
Each statement separately.
Make sense? Double plus double gives double. Double minus double gives double. Is that same thing? But understand one thing, okay? If you ask the contract of plus, the contract of plus is double, double gives double. Fine. But 10.0 plus 20.0 is double. Now why is this important? Yes, you can substitute. So what does it say? Here it says 10.0 minus 20.0, right? What value should be here? Value of what type should be here? Correct. Value of type double, right? This whole thing is double. This whole thing is double, which basically means I can substitute it here, and it's going to work. When you have a type to be substituted, you can either substitute its direct value or expression that gives its type. What matters is you get the value of that type. That is why I keep saying 3 plus 2, do not say, even while saying, right, the value of 3 plus 2 is 5. It is not that. 3 plus 2 is 5. Make sense? Everyone? 10.0 plus 20.0 is 30.0. So if I need 30.0 minus 20.0, I can very well say 10.0 plus 20.0 in its place. That's completely fine. Substitute it. You know the type? Substitute its expression. That gives that type. So once you have type in picture, you can put them together. It's like Lego pieces now. So, right from the 6th standard, shift enter. Press shift enter. Okay, so right from the 6th standard, we used to say, okay, this is the way to draw a circle, right? We used to say it doesn't matter, like child need not understand how to draw a circle. What he should know is how to have a block that draws a circle. So over here, how it draws, how it adds, how it draws a circle, that doesn't matter. We have a circle with us. And then we have something that makes that circle somewhere else, makes it big, makes it small. The question in front of us is how can we put it together like a Lego piece. I have a Lego piece of square, I have some long squares, rectangles, domes, and I want to make a dinosaur. Would you start teaching, you know what, this is a special type of plastic called fluoro, whatever. You won't go that way, right? You will say, okay, these are Lego pieces, this connect to each other, solve it. Ever heard of Tower of Anay? Heard of it? There is a game called Tower of Anay. Not Anay, okay? Anay. So the game basically goes like this. There are 3 or basically any number of rings smaller than each other. And then there are 3 rods. All of them are placed in one rod. You have to transfer it to the 3rd rod. Exactly like that.
So that game is there in G complex.
Yes. But you cannot move them just like that. There are certain restrictions. You can move them one by one, but you cannot place the bigger one on smaller one. A bigger ring on smaller ring. How will you move it? Now obviously there is a set of algorithm for it. Give it to any child, they'll do it. If you try to teach them algorithm, they'll say, I don't understand. But just ask them to do it, they'll do it. That's always the fun. But the thing is, once we know what that is, we know what goes where. In software or in code, they don't look like Lego pieces. Because in Lego pieces we know, right? Oh, these 4 dots can go in this cube wherever these 4 inputs are present. That's how they stick together. That's how we can build a bigger picture. But unless we know the contracts and the types, we do not know what fits where. That is why those types are important. Anyways, keep it like this. 10.0 plus 20.0, fine. Let us do, let us put 2 pictures together. Here we are putting 2 numbers together. We are getting a 3rd number. Let us put 2 pictures together. But understand one thing, okay? 2 numbers, output is just 1 number. We need to put 2 pictures. Output should be just 1 picture. Not what is there in the picture. Like the final thing that I carry should be just 1, right? So how do we do that? I'll leave it like this. What do I have here?
Fixed text.
Correct? Now, I'll just write this slightly differently, okay, for it to make sense. I would say, take a look at this, okay? Def number 1 is equal to 10. Def number 2 is equal to 20. Okay? Now here, I want to say write, take a look at that, write, and I want to do something such that I write only 1 picture here, only 1, sorry, only 1 number, sorry, def some number which is of type double is equal to, for now say 0, and then I will put this some number here. Alright? What will this do over there? 0.0. Fine? Now, I want this sum number to be obtained. Need not be the value, okay? Need not be 0. But I do not want to change this. Only one number is put over here. I do not want to put two numbers here. Okay. I want this sum number to be obtained from number 1 and number 2. How?
And after is equal to the number 1.
So after some number, because I need a double value, I need only one single double value. Given two double values, how do I get one single double value? Look at the contracts. And there is one more. Double minus double also. Right? So let us do that. So number 1 plus number 2. And then this works. Alright? Contracts. We know what we want to achieve. We look at the contract. We see what do we need. We trace back. Fine? All of that is important. By the way, kind of special attention here. Okay? I have put a line here. Here we have picture, that scale and all that thing. But here I have written these two things separately. You know why? Do you see what is there in quotes versus what is not there in quotes here? Right? Here only this part is in quotes. Now, here only this part is in quotes. See that? But here the whole thing is in quotes. Keep in mind, here this whole thing is the name of the function. Because quotes are to be written as is. This is the name of the function, but over here, this is just like this double here. You put its value in place. Similarly, over here, this picture is not in quotes. You have to put a value of type picture here. That is what it is trying to tell. Okay? So those quotes and all those things are important. Do not confuse between those two. We will see white bands. Similarly, I'll ignore these two parts now. Let us focus and get these two on top. And I want some picture of that picture, and I will currently say empty picture. But what I need is, when I say draw, I only want to have one draw, just one draw, not circle.draw and rect.draw, only one draw. The whole thing should have only one draw. So that I say draw and draws everything for me, whatever I need to be drawn, right? Currently it won't draw anything, just like we had a 0 written, right? So this is like 0 now. Okay? How will I now get a picture to be drawn? Just one picture value, one single picture value made up of two pictures. Can you look at there where I can combine two separate picture values and get one single picture value? It's clear over there, right? Third one. Pixtag is a function, takes two values of picture, gives a single value of picture. So we need a single value of picture, but we have two pictures over there. So I will say pixtag. Okay. This is it. It's at P1, P2. Correct. Circle and rect, right? So I'll just actually get this down. So like this. So what do we need first? Circle and So I put two of them together in pixtag. So it will combine, give me a single picture value, which will then be drawn, and I'll have both of them drawn together. What happened?
Dot volume.
No, this is fine. What is this picture? There. Sorry. It was highlighted. Is that correct? One single picture value made up of two separate pictures. Combined picture. What if we have third picture? Now combine them together.
We have to combine two pictures first and then.
No, we have to put circle correct.
That is one way. But given that, let us say pixtag takes only two picture values, not
Two
three.
pictures, we have to define one picture having.
Circle we can some picture and
Some picture and-
Let us say
Some picture and circle.
some picture and circle.
Some picture and circle B.
or let us copy this out somewhere else. Okay? Let us copy this whole thing somewhere else. Okay, here. And I'll comment, I'll keep it like this for now. Okay? What is this whole thing? What is this whole thing?
Some
Picture. This whole thing is a picture. Whole thing, okay? Now to combine two pictures, I need again a pixtag. Okay, so I have a pixtag. Okay? One of them is going to be circle big, followed by I need another picture value. Do I already have another single picture value? This one. What did we do just now? No. Because the whole thing is one value. Is this making sense now? This is the composition. You can keep going like this.
Not put it directly.
You can put directly. What I am trying to show is the concept of composition. Because this is especially useful if you now want to combine it in a recursion. So understand one thing, okay? Rect is a picture, circle is a picture, pixtag called with two picture values is a picture. So this whole thing is a picture. So this whole thing is a picture, this is also a picture. Now I have two pictures. Even though you will see many in it, right? It's like 10 plus 10. It's 30. 10 plus 10 is not 10 plus 10. 10 plus 10 is 30. So pixtag of these two is picture. Picture, picture, then I can again put another pixtag. And I can keep going like this. Pixtag into another pixtag, into another pixtag, into another pixtag, it grows. Kind of same. But understand the key rule, okay? Here is a key rule. You have to get, if you need to get animations working comfortably, you have to have only one draw in the entire thing. No matter how many shapes you want to draw, at the end there should be a single draw. Not 10, 20, 100. exercise, right? Try having the fourth one. And try combining 4, 1 with just one rule. Every pitch deck should take only 2 pictures.
Here only. Here.
You can try it on computer. Ideally, you should do it actually on paper, it is better because then you can actually start typing. As an exercise later. Yeah, we will do all of it. Yeah. But every pitch deck should take only 2 pictures.
One more picture we have to define now.
Yes. Anything you can try, but not now.
What's the statement? Then, question.
Question will share later. Question will share later. I'm just saying. As a try and error. This is good enough? Okay? Now that we know how to combine things together, right? Let us look at transformations. I'll keep this sum picture here. And I'll say picture dot empty picture, and I'll only keep rect. Okay? I'll just keep the rect part. Good enough? I'm only keeping the rect part. Can everyone see? Only the rect part. Okay? What would this draw me correctly? Nothing. I want it to draw me rect. How will I? Give me various options in which I can get him to draw rect. Various options. Let's see. This one doesn't change. The draw doesn't change. You can change what is there here. Or anything else. Draw rect. Fine. What is the other way? Draw picture dot rect 100, 100. Okay. What is the third way?
Some picture dot.
Yeah. Some picture is equal to rect. What is the fourth way?
Picture dot draw.
Some picture is equal to picture dot write 100, 100. Anything could be substituted with anything else. Make sense? What you need to draw should come here. But that can come in any form. I can directly put picture dot write 100, 100 here. Or directly put rect here. Or I can put rect here and then put this here. Make sense? All the combinations. Try doing each one of them to make sense. It will exactly draw the same thing with no errors because they are values. It is always better we do it on paper, okay, not on computer. So, one example is I directly put the rect here. And then it draws me that. Other option is I put the rect here and then put this here. And it gives me the same thing. Other option is I directly put this here. Okay? If you want to give yourself some pain, there are always smart people like that, right? Who I don't understand whether they give pain to themselves or to others. So you can do that way also. You can do this. Pick stack. Okay? One of them is picture empty and second one is rect. This, and if I ask you to draw some picture, this will draw exactly the same thing. You know why? Because this is nothing but, instead of printing 10, I print 10 plus 0. 10 plus 0 is 10. So that, this is the rect, this is like 0, this is like adding them together. produces exactly the same thing. If you still want to put your teacher in trouble during correction, you can put pixtag picture.empty this whole thing again.
But we were told there is some bug in the.
There are always words.
That's why we put that picture in curly braces.
Picture dot thing. So 10 grams you require pixtag to be put together, otherwise it becomes too confusing. Okay, good enough? Okay? Let us have rotated square. How do you want to have rotated square? So we have a rack. Let us now say, I'll change the name of this, okay? Take a look at this, okay? Just be careful and note every step. Rather than doing it on computer, try and note it down on the paper. The more you solve it on the paper, the better it gets. Because in paper you can just strike off, easily substitute it. If you try doing it on the computer, right, eventually things will go from the screen and you need to do it on the head. Then you get nightmares. So I have pictured a rack, then I have rotated rack. Okay, this is easy, right? This is very easy. Rack dot. Take a look at that. What gives me rotated one? I again need a single picture. But by the name, this looks like this is going to give me rotation.
That's rotated.
So I can call dot that's rotated. It is not that's rotated. Okay? It is dot that's rotated. But before that should come a picture value. And after that should come a both are inputs. This is also the input.
Double value.
See, this is the function, okay? Just like this, right? One input is here, one input is here. And just like that, dot that's rotated, it has two inputs. One is here, other is there. So, dot that's rotated, one input is the picture value. This is the angle. And then you get another picture. Okay? So let us try. So what I need is dot that's rotated. But dot that's rotated does not work on its own. It needs two inputs. One goes on the left side before the dot. What is that?
Name.
Rect. Because rect is a
Picture.
and then another input goes on the right, which is a
Double.
double. Dot zero. And I put this rotated right here. And it gives me the same thing. It didn't rotate. Why?
0.
Zero. Rotation is 0. Now I slowly increase. I say 10. Okay? 20. 30. 40. So what am I doing? I'm changing it here. What I want to say is rotated rect should rotate by any angle. How do I make that any?
Take input.
Take input. So over here, I would say that's rotated by any angle, and that angle should appear here before the quotes. Can you look at that? See, this input, right? This input here should be appearing here. This, whatever I give here, should come here. Can you guess what is the type of this angle? Why? Because that's rotated takes
Double.
But will this work now?
No, you have to give it to us.
You have to give the input here. So now I can say 0.0 there. I say 10 there. I say 20 there. And say 30 there. Good enough? So, if I need to animate, I have to significantly change that value. If I need to animate, I have to significantly change that value. Did you notice something? Now, it is important to get some control over the language. Precision is important. A lot of time what happens is a lot of YouTube videos, right? They say algorithms are like recipes. But no. Recipes are descriptions. Algorithms are definitions. What is the difference between a description and a definition? Who's the driver? One who drives a car. Is a description. It cannot be a definition. You know why? It is a cyclic definition. Who is the driver? One who drives a car. The drive comes again. That's a description, that's not a definition. There has to be a precision. If you want to say, one way we can say changing the value of input gives us a different rotated rectangle. But that is not very precise. If you want, you have animations, there has to be some precision in what we say. The precision looks like this. Did you observe something when I was changing the value and increasing the value? If I increase the angle, the rectangle rotates counterclockwise. If I decrease the angle, it rotates clockwise. This is the description you need. Or this is the definition you need. If you increase the angle, rectangle rotates clockwise. Sorry, anti-clockwise. If you decrease the angle, rectangle rotates clockwise. So if you want to rotate but anti-clockwise, what should you do to angle? Add or subtract? Add. If you want to rotate it clockwise, what should you do? Add or subtract? That's the definition part. You need to have your problem statement defined correctly. So this draw, this is fine. There is no problem with that. The problem is this 30 always stays 30. So we need a way to say, you know what? We need a value there which is either increasing or decreasing. Which is either increasing or decreasing. So essentially, we need a function. An animation function. Okay? And that animation function basically looks like this. It is supposed to take a parameter, which is obviously the changing value. It is supposed to draw as per that input, and then it is supposed to change the input. Or not rather change the input, it should tell what is the next input. Three things. You have an input, you draw for that input, and you specify what is the next input. Remember, they are values, you cannot change them. But you can build some expression of what the next value looks like. Okay? So, if I want to rotate it counterclockwise, what should my initial input be? Initial, when the animation starts. Could be anything. Let's say 0. Could be anything. Note it down. Right, students? ZERO. Not ZERO, okay, 0.0. Okay? If you want to rotate counterclockwise, what initial value should we take? Any value, any double value. Take any double value. Write your own double value. Your own. I will take 0. You write 10. You write 20. Any double value. Good enough? Because it should be of type double. Why? What is the changing value here? This is the changing value. What is its type? Double. And we are not trying to be exact. So, any value of type double. I take 0, whatever. Understand that there is some initial value. Write it somewhere, initial value to be this. Whatever is there in your mind. Now, I have that initial value with me. Given that initial value, let us say that initial value is called angle. How will I write my draw statement? How will your draw statement look like if you have your initial value with a name, whatever, you have your current input with the name angle? How will you write it? Say it, do not write it. Because then you are going to dictate it to me. How will you write it? Obviously it is going to be draw, then it is going to be rotated rectangle, and in bracket, angle. Angle. I have angle as the input with me. That angle I will put there. Whatever it is my current input. That I will put there. And after that, before it draws the other one, I need to tell it what will give me the next angle. What we want to do here? Yeah, why? Anti-clockwise. But rather than increment, right, let us talk more precise. Plus 1. Now, should we do it?
Yes.
You are going to dictate it to me, okay? But I am going to write a structure, skeleton. But all of you will dictate it to me. Animate with state. Animate with state. Okay? Keep this in mind, okay? And there is an initial state here. And what my inputs are going to be here in this case? Angle, right? So I will change this to angle. Now, what should I write as the initial state? I will select one. You can give me any initial state. Okay? Then I am going to say, always before you draw something, what you should do? We are doing it right from the 6th stand. Erase. Erase picture. Now with angle as the input, how should I draw the rectangle rotated to that angle? You will start dictating it to me. No, that is already there. I need to draw. For this angle input, I need to draw. D-R-A-W. Okay, open bracket. Rotated rect.
Angle.
Plus 1.
Why?
No.
I want to draw it for this angle. Do not confuse two things.
Angle close. Now you are doing this.
Good enough?
Now you are doing this.
And now I need to tell what will give it the next value of the angle. Not angle is equal to angle. You cannot do that. See, angle is a value. You cannot change a value. If you say angle is equal to angle plus 1, you are like changing the angle. All you will say is angle plus 1. See, this is because I want to erase it. This is how I want to draw it for the given input value. Given input value, draw it only for the given input value. And after you draw it, at the end, you define what the next angle looks like. Next, you always remember, the scope is very limited. You are drawing only for the single one. And if I run this, okay, I want to rotate this anti-clockwise. Sorry, clockwise. Does it matter if I start it from angle 10? Doesn't matter. Doesn't matter. Obviously, the initial one will be drawn at rotated at angle 10. That's it. It doesn't matter. Do not waste brain power into things that do not matter. Is this clear? Should we make it slightly more complicated? Two pictures. Let us do two pictures. But before that, right, let us do a slightly more simpler change. This one is rotating from a point. Take a look at this. See the center. Rotating from a point. I do not want that. I want my rectangle itself to be at the center. So it rotates from the center. Okay? All of you think for 2 minutes. It's one line change. Something is funny here. Let me just save it and restart this. So, give me one simple step. Try and understand one thing. What do I need for a circle to rotate from its center and rather than a vertex? What do I need? Think of it. No. You have to define what the shape should be. That is how you will achieve it. But first define what the shape should be. How will you describe or how will you define me? Not describe, okay? Try and be precise. How will you define this rect to me? define the rect in as precise manner as possible. Now this is where a bit of definition comes in. Can I rub that? Everyone has it? Now I will use it. Okay? You see, whenever the problem statement changes, right, even though it looks same, they are not same. It looks like, oh, you know what, it's the same thing. I just need it to be rotated. No. Always redefine your statement. If you find it difficult to define using words, define it using a picture. X, Y? Which is X, which is Y? X and Y. Why? Why is this X and this is Y? Because someone says. Okay? So this is X and this is Y. Alright? Now I say rect 100, 100. Who can draw me what it looks like? Here on the board. Let me mark the points. Okay? 0, 50, 100, 150, 200, 50, 100, 150, 200. How will it draw? Whenever we do this, right, try and describe your situation as good as possible. Okay? Where is the center?
Sir, झाले. Screen नीट झाले.
I know. I'm taking an easier example because the response will be slightly complicated. This is the center. Always define it properly. Okay? Now tell me what that rect looks like. If it is difficult, only draw that rect and see what it looks like. It is not just any rectangle. I know that draws me a rectangle, but it is not any rectangle. It is having a special position also. What is that position? That position is here. Like this. Here. Here. Like this. I can rub that part. Correct? Okay? Because we need to know where to solve the problem. Half the time, we solve the problem, obviously, we take a lot of efforts, right? We just solve it in the wrong place. Municipality चे उदाहरण ना, आम्ही नळ भटकळ. Ever heard that everybody wants to buy something whenever they see 20% discount? All of us do it. All of us do it. 20% discount. Let's go and buy something. Why? Because we want to save money. Then at the end of the month, what happened to my bank account? Wow, what happened just now? You were supposed to save money. But to save money, right, you should not buy. Buying at discount is not saving money. Makes sense, right? So it is like that. We need to know where to solve the problem. See, there is a rotation and then there is a rectangle. You need to identify who's wrong. And then fix who's wrong here. There is a rect method and then there is rotated rect. Lot of time people fix something which is not required and then they struggle. So let us fix something that is required. Now we have a rect that is following a normal process. Picture.rect is defined that it will draw it this way. Similarly, that's rotated is also defined in some particular way. What is it defined as? It rotates always from center of this center. It always rotates from this center. Right? So is that's rotated a problem or is rect a problem? Rect a problem. So if that's rotated will behave how that's rotated is going to be. It will rotate from the center. You cannot change it. That's rotated takes no other parameter, no other origin. That's rotated is that's rotated. It will always rotate it from the center. Simple. Who's the problem maker? Rect is the problem maker because it gives it here. Where should that be? How should it look like to us? If we want to make it correct, how should that be?
Shift back.
It should be here. This is minus 100. It should rather look like this.
50.
Minus
50. Minus 50.
Minus 50.
Minus 50.
Sir, minus 50.
Minus 50.
Sorry, this is minus 50. Sorry. Correct.
Also, y is minus 50.
Right? So similarly, this will be minus 50. Now, we have it here, but we want our rect, this one, not here, but here. So first of all, ask yourself, okay, is this 2b square to the left of this or to the right of that? Is this to the left of this or right of it? Left. Left is what? Positive, negative.
Negative.
Right? So we want to shift it. We want to shift it left. We want to shift it left. By how much amount? 50. Obviously that is negative. Okay? Now, is the 2b position below it or above it? Below is what? So below by? Why? Because you can see this, right? See, this is 50. Similarly, this is 50. If you want to shift or move, what's the function we to use? That's translated. So the function we need to use is dot that's translated. See, I am solving it on paper. I am not doing it there. Okay? Now, what is the x side change? Minus 50. And what is the y side change? Okay? Good enough? Now, who is the problem? That is what we need to see. Here we need to put a value. Here we need to picture value. We need to put a picture value here. There should be something missing here. They have defined, correct? So either you can put it here. That solves the problem for everything in simplest way, right? We need a picture value there. See, picture.write 100, 100 is picture.write 100, 100 is what? Picture. So I can say dot that's translated minus 50. You can put it here also. That is also possible.
So axis.
Show axis. You can say show axis. You can see it, right? We first found the point at which there is a problem. We found the point at which there is a problem. We correctly had to identify. We knew rect was a problem because picture.rect was doing what it is supposed to be, but rect wasn't. We wanted rect to be rotated, but rect was drawing it in the wrong place. Alright?
So can we take that's rotated on top with a rectangle?
Can we take that's rotated? Yeah, you can. You define that's rotated. Which one?
Second line.
This one?
Rotate.
You want to have this one here?
Yes, sir.
You can have this one here, but then you need to pass this angle to rect. Okay? Good enough? I just tweak it, okay? I tweak it a bit. Let us see some complexities, right?
So can you put it down after rotation?
Where? If you put that's translated after that's rotated, see that is why it is important what you want to achieve. Why did we put that's translated? Because rotation happens from the center. So you have to fix it before it is rotated, not after it is rotated. Rotation was correct, it was happening from the center. We put that's translated before it because we had to fix the position of the square before we rotated. Rotation was correct. So if your glass of water is having an impurity, will you fix it at the tap level or at the glass level? Tap level. That's what we did. We were having an impure square before, we fixed it later. But let us make it slightly more this. I want the square to be here. This center of the square, I want this center of the square to be at 150 on the x-axis, not on the y-axis, okay? I want this square to be shifted here. This square to be shifted here. Now, let me ask you this. Obviously there is a shifting, okay? So, now, hear me out, okay? Hear me out. Let me rub this. Because this is no longer a picture, right? I mean, this is no longer our reality. This is our reality. Let me draw it here. This is what our reality looks like. Okay? I want my square to be here. This is the reality. This is where the center is. I want my square to be here and then rotating from 150. Everyone getting it? I want this square to rotate from here like this, not like this. I want this to rotate from this as the center, this as the center. Okay? But before that, we want to move something that we have here. Your definitions matter, okay? Your definitions matter. I want to move this, which is something over here.
Center.
Right? I want to move this center here. If I want to move, what is it? Correct. So I need to have dot that's translated. Now here some picture value needs to be there. Hold on. Always you need to pass two values. Correct? What is the exchange? This point till this point. How much is that?
150.
150.
Positive or negative?
Positive.
150. What is the up or down? Stays same. Fine. Now we need to we know this is what is this case, right? But we have a question to identify. Should this be this rect that should get translated, or should it be this whole thing that gets translated?
Whole thing.
Whole thing.
Why the whole thing?
Because the rotation between the center should also be transferred.
Because if you move it first,
0,03
the rotation will always happen from the center. So if you move, before you rotate, if you move something here, the rotation will happen from the center. So your circle square will go like this. Before rotation, if you move, see, rotation you cannot change. You just cannot change what happens to rotation. Rotation is like adamant boy in the class. I am never wrong. I am going to sit opposite to the blackboard. If teacher wants to teach me, let him come. I am not changing my head. It is like that. Nobody has a student like that, right? So argue. Maybe they are next level. It's very interesting to be teacher sometimes, especially the rules of CC being in place. Our teachers were very good. They had a very nice method of finishing the class. Come forward, put your hand upside down. One boy now, everyone else quiet. This is how class should be. Is it recorded?
We'll edit it.
Or maybe only cut that part and make a social media sensation out of it. That's how it works, right? Anyways, so where should we put where?
After rotation.
After it is rotated. Everyone understands why? Because if you move it, rotation is not going to change. So what you want is not a moved square to be rotated. You want the rotated square to be moved. In the first case, in this case, we wanted a moved square to be rotated. Because the square was in a wrong place. It was possible to move the square because rotation doesn't change. So we had to move the square. But now we have a rotating square which we need to shift.
Before angle -1.
So, where?
No, under that.
No, sir, no.
So now where should you put? So this is, see, we have this Lego block, okay? We have this whole Lego block. If I could just hold this and then move. I need to move this
Dot angle
either here or here.
this after angle.
After here. Can you dictate me what I should write here? See, huh?
Dot X.
This whole thing is a
Picture.
this whole thing is a picture. So
Translated.
150,
150,
and I have it rotating there. Okay? That is moved for a different reason because our rotation should happen from the center.
Can you remove that translated and
Eh?
the previous step we are using dot that's translated. Could you remove it and just see how it passes?
If you remove that, it will rotate from this point will move here. See,
It is moving from the point.
Moving from the point. Because it was moving from the point, we actually shifted it. By the way, by the rule of substitution, because substitution is allowed, I can get rid of this first line. And whatever is there here, right, from here till here, I can substitute it here and things will work. Rule of substitution, you can go both ways. Okay? Now, let us do some few changes, right? It is rotating, that is fine. I also want it to be moving. Or no? That's later. I want it to rotate at two different points. Two squares at two different places. One is here. One is here. Another one here.
It's flip text also. It's text.
Correct. So we need one picture. That is correct. But now I need to make it twice. So obviously you need a fixed stack. Okay. So what if I do a pick stack and in the pick stack I put this whole thing twice? This whole thing twice. Okay? So you know what I'll do? I'll say pick stack. Then this comes here. And I'll just copy this whole thing once more. Can you see it? What I've done? Same thing, twice. And if I run this, what happens? Well, nothing happens. Why? It is on top of each other. But I want second one to be on the other side.
Minus 1.
So there is one more which I didn't tell before. There are two ways of doing it. One is I either say this as minus and things would be fine, or I keep this same and say dot with rotation changes because it becomes a mirror copy. Flip X is like a mirror. These are called behaviors. It's exactly behaving like a mirror.
Found different types.
Different directions. So one here, one there.
Rotation in different directions.
Yeah, so you just rotate the whole thing. Rotate once more below. So this is, oh yeah, so that was a good question. So let me first, always before you do trial and error, right? Try and get your, it takes a practice, but try and ask yourself, right? I do not want it to rotate here. I want it to rotate here, minus 150. Or maybe positive 150, whatever. What should I do? I have this with me. I want the second one to rotate here or here. What should I do? So it's rotating here, right? See, it is already rotating here. Okay? Not translate. Translate is obviously one way. Is there a better way? Ask yourself. Here, I want it to come like this. What does that do?
Minus 1. That's it will rotate from the center.
So like this.
0,
I have it here.
Huh.
I want to get it here. That's a rotation.
Full pick stack is rotated.
Not full. Not full. The second one.
Change 0. 150 to 0 and 0 to 1.
One option is we say that's rotated by minus 90. Right? Because we rotated it.
But say minus 150.
Translate is incorrect.
The second one minus 150.
Yeah. Or
With flipped axis.
Or the second one, second option is put minus 150.
150 and make it 0. 150.
And make x-axis 0.
0.
So can we rotate one clockwise, one anti-clockwise?
Yes. Minus
Yeah.
150.
Here, one of them becomes minus.
Yeah, minus it.
There you go. One of them becomes minus. No.
Yes.
This one is going like this, but this point is going like this. One is clockwise, one is anti-clockwise.
Yes.
Right? Or if you put them together, because one of them is rotating in or rather let me say 150, 0 itself, same point. See,
Nice. Yeah.
now understand one thing, this whole thing, right, is picture. This whole thing is picture.
One
One picture. This whole thing is one picture. So I can compose this whole thing in another picture. Right? So it will go like this. I take this whole thing. Take it out. Say pick stack. And I need to give it two pictures, right? I need to give two pictures to it. So one. And the same thing I'll give again. Same thing, okay? Same thing I'll give again. Doesn't look much, right? But what will happen if I say dot flip text to this? Now, this whole thing, right, from here till here, is a picture. So again, that can be put in a pick stack, and the second one could be rotated. The flip 5 won't work. Flip 5, somebody should be below or up, then it will come down. See how I am building things up, okay? This is a composition. Keep saying composition, problem solving, decomposition, composition, whatever that was till now. This is composition. Okay? So let us put this further. This whole thing from here till here is a picture. Whole thing. Yeah. Make it bigger. Essentially, what are we doing? We have the same basic shape. just merged in different ways.
So can we scale it as well?
You can do whatever you want to do with it.
We'll try.
Good enough? Okay? I just want to show you how complicated it can get, right? This whole thing is a fixed stack. Whole thing is a picture. So at one level, right, you should stop thinking that it is a fixed stack. The whole thing, whether it is a fixed stack or big dot rectangle, the whole thing is a picture. And just like something is a number and you can do addition, subtraction, multiplication, division with it, if you have a picture, you can do translation, rotation, scaling, whatever you want to do with it. Okay? So we will do scaling, but we will do it in a something way that it probably would have looked from the other side, would have looked absolutely complicated. So, now this whole thing is a picture. This whole thing. We used to imagine that, you know what, probably only circle is circle or rectangles are pictures. But no, fixed stack is also a picture. Okay. So I will remove this whole thing. And what I will do is put another fixed stack. And I will copy the same thing again, okay? This is from the previous one. This is from the new one. See, I have copied the same thing again. Can you see it? Same thing that I had. I copied it again, put it in the fixed stack. But this time, the second one which is there, right? This whole thing is a picture, right? I will rotate it by 90 degrees. And what you get is that. Try doing this if you are trying individual draws, and you will see the problem. That is why we compose. Okay? Now here is a basic question to all, okay? While everything is fresh in mind, right? Now we have it here. Now I want this whole thing, right? Imagine this is a screen now. Imagine this is a screen. I want this whole thing to continuously rotate. I want this whole thing to continuously rotate like this. So, if you want anything to be rotated, right? Understand this one thing, okay? If you want anything to be rotated, what do you want? What do you need? Angle is there, but which function? So you need that's rotated. Sorry, it is not that's rotated. It is dot that's rotated. It is dot that's rotated. And I want it to rotate by the same angle at which this one is rotating. So what should be the input? Angle. But what? Which value? Which picture value?
Rotated right. So down right.
Rotated right.
So there are two options where I can put it, okay? Actually what I need is this entire pick stack value from here till here to be rotated. So either I can put it here because I have access to the value angle, or there is another point where I have access to the value angle, which is here. You can choose anywhere, but that looks a bit complicated. In case I have to copy it and again put it in a picture, right? That will become complicated, right? So I would put it here. This whole thing is a picture. This whole thing is a picture, right? So if this whole thing is a picture, I can put dots translated after it. Rotated, sorry.
Sir, how we can do it now? After that's rotated 90, there we have to put.
Where? Not here. This one is different. This one is different.
Okay, so there we have to.
You will need to do it here. Understood, right? Good enough? Is everyone clear what are we doing? Merry-go-round. That's a merry-go-round. I'll share the file. Do not take the photo, I'll share the file. Rather write things down.
दोन म्हटले
दोन एकठांय करून मागीरचो दोन पहिले तुमची दोन
You can see the mirror here, right?
त्याची कॉपी कंप्लीट
You can see the mirror here. See, this function pick stacked with this version, only the angles being different. Now that gives us a pick stack. Then we took the whole new picture value, put it in a bigger pick stack, and said the other one is flip text. Then we took this whole one, made even a bigger pick stack, copied it again, and rotated the whole thing by 90. Finally, we rotated the whole thing by the same changing angle. We have the whole thing. Did you notice an illusion here? There is an illusion here. If you notice, right? Notice the square, okay? Does it look like one is not rotating at all?
Yes.
But both of them are rotating.
Yes.
But the angle by which it rotates, right, from one side is the same angle by which it rotates on the other side. Because of which it looks like it is not rotating at all. there is actually a real life object which witnesses the same thing. Not Earth. Moon. If you look at the moon, right, you see the same side of the moon. Doesn't matter, you never see the other side. But it doesn't mean moon is not rotating. But the rate at which moon is rotating is the same rate at which it is moving around the earth. So we always see the same section. The same thing. I'll share this file, okay? But the final one. Again, this is entirely made with pictures. So, you have a pick stack, but now we are not doing pick stack of pick stack of pick stack. We are saying like all the pictures together. It's a shortcut which is given. Okay? So, pick stack of head, right eye, left eye, nose, mouth, and we have all of them defined below. Let's bring some smile. So, what do we have? We have head, we have right eye, left eye, nose, mouth. You have to complete the teddy, okay? The whole teddy is part by part given there somewhere below. Let us complete the whole teddy. This is in the 8th standard. But let us do it together. There is a slight change. There is a slight change of it, but we will do it in the 7th standard. So, what have we used? We have used head, right eye, left eye, nose and mouth. Let us put the ears. There is a left ear and right ear. Okay? So, you have to decide where to put it. Fine, putting is one thing. So, left ear. What happened? I was confused. Why is it giving? So left ear, right ear, right? Is that right? So it is coming in front of his head. You don't want it here. So if you put it down, it comes in front of the head. But if you want it behind, you want it to move. Now there is problem. That was a bug, right? Now if we remove, doesn't matter. It's like 0 plus, so you can always remove it. Now, nose we have already used, right? Mouth is already there. Body. Let us put body and then other parts. Body. Oops.
On the top.
Ah. What about the hand? Left foot. Okay? Is there one more? That's the homework. If you want to put one more in his, there is generally one more down center, right?
Yes.
It's not to make him smile. Because we had enough of contracts, this, values, and things, God knows what. 9, 10, 11, 12, everything we need. To make him smile. In homework we'll make him dance.
Hey, Manisha, please try dance.
So we already have a mouth here. Can we say it? Now we have 30 here, minus 45 and minus 90 here. Okay? 30 is the angle. Okay? So, if we make it 10, 30 is the angle. Oh, 90 is the, let us try, right? 30 is the radius. 90 is the angle of smile. Right? And what do we see here? What do you think it is? I'll write it slightly differently, okay? I'll say this is 90 by 2. So it looks slightly better of what changes together for it to make smile. Is it smiling? Okay, let us give it less of smile. So let us make it 50. Hopefully less means less smile. If we decrease the value and it increases the smile, it will go the other way. Okay? So 90, 50, and then this should also change. Ah, yeah. So if we need to increase the smile, what should we do? Increase this value. Or add something to this 50 continuously. You can start from 0 and keep adding something to it. So it increases the smile. Because changing this, but this has to change together. So if we make it 60, then this has to be 60. Because if you change one, but not change the other,
तशी स्माईल असता तशी स्माईल असता
Sir, why it is written in that format?
so you can correctly see how the changes are occurring.
Why it is written in that format?
expressions
Yeah, that's rotated.
This one?
Yeah.
We'll explain that. That's a separate topic. Let us focus on the animations. Why that arc is like that, we'll talk about. Maybe during the after tea break, right?
2 times.
Before that, let us finish this. Okay? The draw teddy is here. Okay, the draw teddy is here. Now to increase the smile, we know some value needs to increase. Increase means
Smile.
smile. But what is changing? Let us go reverse way. And then we will form out. and that will happen quickly. Okay, everything is in a fixed stack. Everything is in a fixed stack. That means it's a single picture. So let us find the very minimal one. If we change to increase the smile, we need to go to mount and add something to this 90 and this 90. The same value to that. It is that, right? It is that. So let us add something here. Should we say smile factor? So add smile factor here. And add smile factor here. But you need to put this in a bracket. Like this.
Minus sign is inside the bracket.
What is that?
Minus sign outside the bracket.
Minus sign is outside the bracket. Right? Because we want this whole thing to be minus. This whole thing, whatever is here, that whole thing should be minus. Whatever is here, that whole thing. It is not that it is minus 90. Whatever is there, that should be minus here. Okay? And since we have given some value here, which is not known, what should we do? Should come here. Smile factor. What is the type of it?
Double.
See, it is
Double.
that's rotated, correct? Always look at the contract. Now it is going to cry.
That's the value.
It is going to cry because see, it is trying to say here, right? This mouth here is not a direct value now. It needs an input of a smile factor. So we need to give it the input. So let us say 0. Good enough? If we increase it to 5, it should smile more. If we increase it to 10, it should smile even more. Make it 100. Okay? So it is this value which should change for it to smile. So again, if this is what should change, what should we do?
Animate with state.
No. This, we need to get this from as an input, right? So any changing value becomes a argument or an input. This is the changing value for it to smile. So we give it a name. Same thing. Smile factor. And the same smile factor, this is the depth, right? It should come here. Otherwise, it will not find the smile factor. Smile factor of type double. It is still going to cry. Because now this steady does not have the input. So we went one level at a time. We first put it at mouth, hard coded at fixed stack. We put it at the fixed stack level, we changed it at the depth, hard coded at the depth. Hard coded at the drop. That is fine. We did something very similar last time for those rotating squares. And once we reach hard coding at this point, we start using animate with state. So let us now say, what should be our starting value for the smile? 0. Animate with state. Okay, and this is our smile factor, current smile factor. This is our current smile factor. Okay, as always, starts with then this, but not for 0. For the smile factor. What should be the initial value for the smile factor? 0. And what should be the next value for the smile factor?
Wow. Se olvida el
suddenly apply कहते हैं draw टेरी मैंने apply तो draw
-1 it will start decreasing the smile.
draw more separate त्या point ला suddenly apply
Take a look at that.
ते पटले
असे होता how to rectify.
But no, we do not want it to go beyond that value.
Sir, इथे परत एक minus वगैरे. So it will non-stop flow and again it will.
Yes. On the other side, it's actually flipped. But the arc, whether flipped or not, looks the same.
Okay.
So, how to limit it? So here is a possibility. Can I rub that? This is in the 8th slide. We'll anyways get it.
That was so confusing. S plus
S
1.
is that value.
Yes.
Okay? Now, what is our next state? We start with what value? Start with value 0. And our next smile factor is plus 1. Currently what we are doing is we are always increasing it. We are always increasing it. Is that right? But it will keep on increasing. That's why it ends up becoming a circle. So at one point, maybe 180 degrees. So this value gets added to 90, right? So this ends up becoming 90, 91, 92, 93, 94, like that. Till it becomes the whole arc, which is 180. So beyond 180 we shouldn't increase. So we have two possibilities now. Smile factor plus 1 and other one is the current smile factor. If we return this, using this means our next smile factor is incremented by 1. This means our next smile factor is always a smile factor, whatever is the current value, and then it doesn't change. So, take a look at this, okay? If we say smile factor plus 1, take a look at this, okay? It is increasing because smile factor plus 1. But if I don't, and if I only say smile factor, that is my next smile factor is my current smile factor, then it doesn't change. So I have to decide between smile factor plus 1 and smile factor, just smile factor. When and where? When should I do this? When should I do this? So, I need to see everything that I give, right, as a smile factor gets headed to 90. This smile factor goes here. Correct? So I can go till maximum of 180, then it becomes like a proper arc. But not beyond that, then it starts becoming a circle. So, how much can the smile factor go before it becomes more than 180? 90. Correct? So this value can increment from 0. This value can be 0, 1, 2, 3, 4 and can go all the way till 90. But once it becomes 90, stop. It should be this. Correct? So 91, 92, 93, 94. So this is one group, this is another group. Let us identify a pattern. Either I can say if smile factor is 0, then if smile factor is 1, then if smile factor is 2, then keep going. But we have a basic common pattern. This and this. This is when smile factor is less than or equal to 90. And this is else. Because I have included less than equal to here, what remains is always greater than. This is else. So my expression now becomes if smile factor is equal to 90, sorry, is less than, right? Is less than equal to 90, then this else. Now I'll just copy that part here. If smile factor is less than equal to 90, smile factor plus 1, else smile factor. Now it is increasing, stop. It's increasing, stop. It's increasing, stop. You will get it, sir, along with the 8 standard rules. Yes, sir. This is there in the 7. This animation method, right, is there in the 7. What if you want to make a smile face, smiling face bounce? That is smile, not smile, smile, not smile, smile, not smile.
Minus
Now it gets complicated.
minus 1.
Yes, but then it will become less than this, and again it will, so it will not go all the way to 90. So if you say minus 1, if you say minus 1, see, it will not go below. It is not going to go below. See, when it is 90, so when it becomes 91, it goes here and says minus 1. So then it becomes 90. Next time it looks at this, does plus 1. So 90 becomes 91. So the moment it becomes 91, it makes it 90. So it goes between 90 and 91, 90, 91, 90, 91. You can go all the way down, but then you need to have another value. That starts making it complicated. I'll need to introduce more concepts before we do it. But I don't want to go there. Because in the 8th standard, this process gets simplified. So you can do that. This gets simplified. No, that was only to show how it goes, but it is not there in the. It's not there. It's like that Desmos which was. This you will get soon with the 8th standard. You will get it. Till then you can practice the other one. Don't want everything to get confused. specifically after the break. Yes, sir.
That speed and everything is put right.
You will get it, man. This is part of the starter file. This is part of the starter file. You will get it. Don't worry. With this specifically to the smile part after the break, why that arc is that way? That we will do because it is part of the 7th standard.
So we need to do it this way, sir. We need to do it this way. Standard 7.
7th standard is total moving towards pictures. Case is not there. Case is not there. Let us first get some sense, right? What does, you know, all the that's translated, that's rotated, everything is there, right? We did it. Okay? That's rotated, rotates always from center. Okay? Take a look at this. F shape is equal to picture dot arc, and it takes 2. This is that it takes radius and it takes an angle. Okay. Let us say radius is 200 and angle is 90. Let me say show grid. It is helpful, right? And show axis because a lot of things look good after that. So, I just set it up after that. Then finally we'll say draw shape. Now, at this point we should stop on the computer and use paper and trace our understanding. Okay? This is 200. 200. 200. Fine? This is 200. And the arc basically goes like this. This point is 200. And this angle that it has traced for the arc is 90 degrees. So, when we say picture dot arc, it takes 2 parameters. The first parameter is this. This. What we see here. Right? Radius. The second parameter is this. Angle. That's how it is. So now I have traced it on paper. Now once I have it on paper, it becomes slightly easy to understand what is that. Okay? Now when we say smile, it is sort of same angle on this side also and this side also. Correct? So, if I want it to look like how this is, we will see now how this looks like a maths class. But we are not solving anything. Neither we are proving anything. What we want it to look like is not this way. Obviously, we want it to be 90 degrees, but kind of like 45 degrees, this is 200, right? This is minus 200. 45 degrees here and 45 degrees here. This whole thing is 90, right? So essentially we would say now this angle is 90 and this is 200. we get it like this. We get it like this. If we just use picture.r 200, we get it like this. But we want it like this. So our question then is by how much should we rotate? So what do we see here? There are two ways of doing it. Okay? This one line that you see right here, this one line that you see is cutting this part equally, arc equally. But we do not have an equivalent line here. So let us draw an equivalent line. Secondly, so if this is the line cutting this one in two parts. Now this is the whole thing 90, correct? How much is each of this angle? 45. So here, this is 45, this is 45. Fine. This line, if we are ever rotating it, if I need to rotate it, right, I'll move this line and get it till it matches this line. And then I will have this. So essentially I am saying I want to rotate this imaginary line, which is there. By how much?
135.
How did we get 135?
90 plus 45.
45. And this is 90. This is 90. This is 45. So we want 90 plus 45. That is the amount by which I need to rotate. But which direction am I rotating?
Clockwise.
Clockwise. And clockwise is minus. Fine. 90 plus 45. Good enough? 90 plus 45. I am going to rub the whole thing. Except that 90 plus 45. And this is when our entire smile arc is of 90 degrees. Then we have this. Okay? See how I am tracing it. Until I see a pattern. Solve things on paper, use protractor or whatever, imagination, until I see a pattern. Let me rub this. Again, red line, right? Now let us try a smaller one. So this will be 200, but let us say this is 30. And it looks like that. Okay? So we have something of 200 here, equivalently 200 here, but angle is just 30. Like this. Okay? But do we want it this way? We do not want it this way. This angle here is 30. This angle here is 30. Okay, but we don't want it this way. You want it spread equally below. So something like this angle is 30 and it is spread equally. Since it is spread equally on both directions, unless you wanted other kind of smile. Since we want it to spread equally, what does it mean? How much is it this side? How much is it this side? So this is 15. This is 15. Anyways, the way we do it is this is the line, right? We need to rotate, and this is the cutting edge. We imagine another line. This cutting this equal. So how much is this? 15. This is 15. What is this rotation?
105.
This is that 15 plus this 90. This 90, correct? And minus side. So when the smile is of 30 degrees, the formula we get is 90 plus 15. Did you see something interesting? This 90 stays as is. This minus stays as is. But this is half of this. When it is 90, it is 45. When it is 30, it is half of it. It has to be half of it. So, let us give this a try. If I now rotate this, if I now rotate this, that's rotated. How much? Minus
105.
See, this is a common mistake when we add it up, right? They are not testing arithmetic here. So, even when you are drawing pentagon, right, I keep saying do not say 72. It's 360 divided by 5. It's not 72. Be careful or not. It is not 105. I mean, it is 105 technically speaking for us if you want to simplify things. But in all reality, it is minus of 90 plus 45. Right? But in this case, since we are rotating it by 30, we would say it is 90 plus
50.
30 divided by 2.
30 divided by 2. Make sense? If we make this 90, I'll put this also as 90. If I make it 180, I'll make this also as 180.
1,000.
There. So the rule is you find enough examples. Those examples should give you pattern. So the pattern here looks like if you have an angle, then it is 90 plus angle by 2. That's the pattern. Now, we always want this and this to be common, right? We always want this and this to be common. So we can always say, we can give it a common name. Smile angle, and the same smile angle goes here. But now this is a function, right? And this is unknown. So what should we do? Input. Smile angle type
Double.
double. And then we put it that's how we get it. So we now have all the examples with us, right? We know how to draw a smile, we know how to draw a circle, we know how to draw ellipse, correct? If we know how to draw everything, let us draw teddy. That is the activity. Everybody has this drawn? Okay? You all know how teddy looks like, right? So this is how the activity looks like. This is how the activity looks like. Draw teddy. Smiling, crying. Feel free. Turn the smile upside down, cry. Anything that comes to your mind, but limitation is, there are two limitations, okay? You can only use picture dot circle, picture dot rect, picture dot arc, picture dot ellipse. This is the first limitation. Without using, and obviously you can use fixed text. Okay? Draw teddy using this. The other limitation is every fixed text should have only two pictures. Put as many fixed text as you want, but every fixed text should have only two pictures in it. I have just given it. Just because something is given here, it doesn't mean you have to use it, okay? You can give him like whatever, you can give him a table, whatever comes to your mind. So this is one constraint. Second constraint is only a single draw function. Okay? Only a single draw function. Third, have the paperwork first. That's the activity. Tomorrow. Sonal ma'am, tomorrow, right? Tomorrow. All is the right reading. This is just one ma'am? Okay, I'll give another one. Only to draw teddy. Just smiling, obviously.
No, the smile should grow.
Smile should grow.
Drawing teddy and then smiling teddy also.
But first draw the teddy. Can you take a photo of this? Got it? Three things. I walk through the process. How to know which one comes first, which one comes below. I wrote their contract, then I mapped them. That is the important stuff. That is why I asked you to observe it. Share all of it, okay? Just share. What is the very clear there? Very clear. Finally, for what we need. For what you need. Alright? Okay, alright. Let us quickly talk about some few things, okay? This is good enough? Everyone had it? Two more functions we'll talk about. Two more things we'll talk about quickly now. You just listen to me. If you want, just note it down. Do not take it to your head. Do not do it at home. Understand certain type of the functions. That is how we should visualize it. If I have a function called depth increment, right? Depth increment, for whatever given number of type long, it returns me a value of type long. Whatever it is, forget what the name is. What comes after that, that doesn't matter. What do you think this will do? If I give an increasing value, here, what will the output that I get? One number, that is correct, but what will I get? There is a type, but essentially if I give 2, I'll get 3, if I give 3, if I get 4, and if I give 1,000, I'll get 1,001. Correct, right? Okay, then there is a power function. You have heard of power function, right? Power function. So, there is something called as a power function, right? So it takes two values, obviously the number and its exponent, power. Now, what does that mean? For increasing value of power, what happens to the output?
Number times of power.
Correct. So does it go on increasing or it goes on?
It goes on increasing.
It goes on increasing unless the value is 1. If the value is 1, no matter how much you increase its power, it does not increase. all other values it increases. But if the value is less than 0, sorry, the value is less than 1, then for the increasing value of power, it decreases. So it goes like this: x raised to y. If x is greater than equal to 1, increasing y gives increasing value, right? If x, sorry, not equal to 1, if x is equal to 1, increasing y gives 1, always. And if x is greater than 0 but less than 1, increasing y gives decreasing value. Interesting functions, right? They all have different behaviors. What happens when some value increase, what happens when some value decrease. Alright? It doesn't matter what that value is. What is important to know, they are having slightly different behavior. Sometimes we have ever increasing value, sometimes we have conditional. Either it increases or it decreases, depending on whether it is above 1 or less than 1. Fine. There are other set of values, and that is math dot sign. What does this value do? This is very interesting. What does this do? Yeah, but it doesn't matter. But what matters is what does it do to an increasing input. For increasing input, the output changes between -1 and 1. Doesn't matter what you give. Output is always between -1 and 1. You give 1000, it will never cross. It will never become more than -1, or sorry, less than -1, never more than 1. Always in between. Okay? You know what this motion is called? 1, -1, 1. Oscillations. Just different kind of values. Some things are always increasing. Some things either increase or they decrease or stay same or whatever that value is. And something always goes between 1, -1, 1, -1, 1, -1. So if you have something going up, down, left, right continuously, what is that? You should realize something, that there is a sine wave over there, sine function playing a role. Always between two values, nothing beyond that. Will never cross 1 and -1. Never, never, just never. Right? Plus increments if the next value is increasing. Plus decrements if the next value, that is A plus B. If B is increasing, output increases. If B is decreasing, output decreases. Okay? Multiplication. If B, one of them becomes 0, the whole thing goes 0. Isn't it? There are certain properties to be aware of. What is important is to know those properties. What that function means. Sometimes we try and say, okay, what does multiplication mean? 3 times. It's a scaling operation. So if we have a rectangle that looks like this, okay, this is how it generally gets drawn, right? If I start scaling it, not beyond 1, 1 is this is scaled to 1. If I make it scale down to 0.5, what happens? It becomes smaller, like this, half of it. But if I scale it to minus 0.5, what happens? Goes opposite side. So as you come down, right, it becomes 0, 0, 0, 0, 0, and then it changes the side. Minus, right? Multiplication is like scaling. If you start scaling it negatively beyond 0, the whole thing changes. Your x also goes negative, y also goes negative. Every point that was here, if this was 150, 150, this point will become minus 150, 1. Changes. But interestingly enough, if your rectangle itself was like this, here, and if you scale it to negative, what will happen? If you scale it by negative value, negative 0.5 or negative 1, it will go here. Negative gives positive. So whenever you see that scale, right, understand that there is a multiplication. That is what the scaling is. So it multiplies by the same amount, both the sides. Unless you are saying that scaled by x and y, then basically it is. Good enough? Something to remember, just note it down. It's okay even if you forget it. Portion में नहीं है. Till 70.
8th में है.
8 में.
ये है. Can we have one example of this?
17. Isn't it enough? Then I will only forget what I was